What's in the water, and how do we find out? Is it safe for human consumption? These are all very important questions deserving of important answers. As water is necessary for human life, it's important to know that it's safe. For this presentation, individuals were given a sample of water, as well as IR and NMR spectra, mine specifically being of unknown sample 19, 19.1, and 19.2. The goal was to be able to make an inference about what molecules could be in our substance by interpreting the data given to us by the IR and NMR spectrometers. By finding out what characteristics our substances had and comparing it to a given list of molecules with hydrogen bonds, the goal was to accurately predict what was in our water. To quickly summarize, IR spectrometers work by finding the absorption of a photon through infrared waves. This is used to determine the kinds of hydrogen bonds of the substance in question. This helps us to find what functional groups are in our molecules. By understanding the different ranges of absorption and how they correspond with different functional groups, one can accurately put the puzzle pieces together. Similarly, NMR spectrometers use radio waves to excite hydrogen protons and can determine the peaks and ratios of different hydrogens for the unknown substance. This can be used to tell how many and of what ratio to one another are our hydrogen bonds. Looking at our first IR spectra of our unknown substance 19, we can observe the range of absorbance and where the most noticeable peaks are. In this case, 3035.16 wavelengths, where 3150 to 3000 wavelengths indicates the functional group carbon to hydrogen benzene ring. Moving over to our NMR spectra, the first figure shows the IR spectra for our unknown sample 19. The peaks here are shown to be singular with a 1:1 ratio. To compare, looking at table 1 that has our possible molecule candidates, only 3 have a carbon to hydrogen benzene ring, and only one of those 3 has one peak. Looking at table 2 for this molecule being benzene. Following the same trend to decipher our other 2 substances, we can take a look at unknown 19.1's IR and NMR spectra, where the range of absorbance and where most of our noticeable peaks are. In this case, 3368.58 wavelengths, where 3500 to 3100 wavelengths indicates the functional group oxygen to hydrogen, and 2973.46 wavelengths. In this case, 3010 to 2800 wavelengths indicating the functional group carbon to hydrogen singly bonded. And our peaks have a ratio of 1:9. Only one substance on our list of possible candidates has a 1:9 ratio, again looking at table 2, that being T-butanol. Finally, our last unknown substance, 19.2, where the IR spectra shows the range of absorbance and where the most noticeable peaks are, in this case, 551.33 wavelengths, where 650 to 550 wavelengths indicates the functional group carbon to bromine, and 2973.91 wavelengths, again, where 3000 to 2800 wavelengths indicates the functional group carbon to hydrogen singly bonded. The NMR spectra for the unknown substance 19.2 shows 2 peaks with a ratio of 1:3. Of this combo, only one molecule has a carbon to bromine bond, 1,2-dibromo to methyl propane. Now that we have successfully determined what our unknowns are made up of, we can find out if these molecules will kill a man. To quickly review, our unknown substances have turned out to be benzene, T-butanol, and 1,2-dibromo to methyl propane. All 3 of these species have been deemed harmful or at least an irritant to the human body. The Agency for Toxic Substances and Disease Registry describes benzene as, in high doses, fatal. In lesser doses, it still has the potentially, if consumed orally, to cause vomiting, irritation of the stomach, dizziness, sleeping, convulsions, rapid heart rate, and coma. T-butanol is described by PubMed.gov as an irritant for the skin and eyes, and if ingested in large amounts, is toxic for many organs such as the bladder and kidneys. 1,2-dibromo-2-methanol-propane is similarly stated as an irritant for the skin and eyes, and if ingested may cause disruptions in the digestive tract. None of these substances are safe for human consumption, and even human touch, in many cases, may be negative. While the environmental effects of the substances may be lesser than the effects they have on humans, these compounds released into the bodies of water generally destructive, however, they still have an impact. Benzene, while found frequently in the environment, breaks down slowly in water and soil. Similarly, T-butanol and 1,2-dibromo-2-methanol-propane are simply described as toxic, and it is recommended to be kept away from bodies of water and soil by incab.org and PubChem. To conclude, it is both important to understand what you or a company might be offering to their neighbors or customers by using different wavelengths and recording the absorbance rate of molecules and how they're affected can clue a scientist into decrypting what exactly the substance is. Thank you for listening to my presentation.